A very good morning to all of you. In today's lecture, we're going to discuss WDM, that is wavelength division multiplexing technique. Again, it is an analog multiplexing technique. Earlier, we have discussed frequency division multiplexing technique. So, what is happening right now? Let's catch this wavelength division multiplexing technique. It is used to utilize the high data capability of fiber optic cable in order to meet a long distance communication. Okay. So, the process is very much similar to multiplexing and demultiplexing. Now, what is happening right now? As far as fiber optic is concerned, it is related to the light. So, light is having its own wavelength. If we are having 3 users, if we are having 3 light, the wavelength of individual light will be lambda 1, lambda 2 and lambda 3. Here lambda is being designated as the wavelength, right. So, lambda 1, lambda 2, lambda 3 are the 3 lights, and here we are having a multiplexing process. Okay. After multiplexing, we are having the combination of, or we are having an addition of 3 wavelengths, lambda 2, lambda 1, lambda 2 and lambda 3, and again it is being bifurcated with the help of WDM to lambda 1, lambda 2 and lambda 3, lambda 1, lambda 2 and lambda 3. This is the simple process, this is a simple concept of WDM, but as far as its main phenomena is concerned, that is being used for optical fiber communication system. WDM is an analog multiplexing technique. It is used to combine optical signals. Here we are having optical signals, and this is prism. This is prism. This is prism and this is prism. One prism is used for multiplexing and another prism is used for demultiplexing. Here we are having lambda 1, lambda 2, lambda 3, and these lights are incident on this prism, right. So, lambda 1 is incident on this prism. Here it will deal with the refraction process. Okay. After refraction, it is again focusing on a single point. As far as lambda 2 is concerned, again it is meeting the refraction process. Here also we are having a combined combination of lambda 1 and lambda 2, and for lambda 3 also, after being incident on this prism, the refraction process is there, and after refraction process it is also being focused to this point where lambda 1 and lambda 2 was is there. So, here lambda 1, lambda 2 and lambda 3 are meeting, and they are focusing on single line communication, right. So, this is used for long distance communication, or you can say we are having a standard, or we can say a new communication based phenomena, that is optical fiber communication system, which we are using nowadays. So, all these 3, lambda 1, lambda 2 and lambda 3 are combined, and it is being sent to the demultiplexer, where a prism is there, and these lines are being again refracted through this prism in order to bifurcate lambda 1, lambda 2 and lambda 3 accordingly at the output. So, you see that in WDM also we are having a concept of multiplexer and demultiplexer, how the optical signals are combined to form a composite signal, and that composite signals are then used for optical fiber communication system in order to form a good link, or in order to flow a good data rate, in order to get a high speed of data from one side to another side. Okay. So, this was all about WDM. In my next lecture, we will be dealing with TDM, that is a digital multiplexing technique, that is time division multiplexing technique. Thank you.